Hello, everybody. I wanted to make a quick video. I noticed some people didn't get the work done last week and or didn't do so well on it. And so let's talk about some tape diagrams because this week is also going to talk about diagrams, and they're kind of a big deal, especially in this curriculum. So let's look at this. It's kind of a nice way to represent equations. So let's look at the first one. I see three boxes here. I see an 11 and two X's. So what does that tell me? And then I see this 23 down here. I'm wondering if you guys are comfortable and confident kind of interpreting what that means. If I see two X's, I know that those two X's are the same, right? They stand for the same integer, the same number. Those X's are both the same. 11 looks like it probably is a little bigger than the two X's. And then all together, this whole thing equals 23 if I put all those things together. So let's see if we can write an equation to represent this tape diagram. So that I'm just going to write down what I see. So I see an 11. And I see that we're putting it together with these things. And when we put things together to equal something else, we're adding. So I'm going to put 11 plus, how many X's do I have? I have 2. So 11 plus 2X equals 23. Now to solve this, I want to remember I'm always trying to work my way in toward the X to get that thing by itself. I want to get rid of anything else that's kind of hanging off the edges first. So I'm going to subtract the 11. And in algebra, whatever we do to one side, we got to do to the other. So I'm going to subtract those 11s. These are going to cancel because 11 minus 11 is nothing. I have now 2X equals 23 minus 11 is 12. So now I ask myself, what is that X doing with that 2? Well, they're multiplying, and I know that in algebra I do the opposite. So I'm going to divide both sides by 2. These are going to cancel out, and now I just have X equals 6. Because 12 divided by 2 is 6. So let's see if that would work. So if I went back to our diagram and I said 11 plus 6, that would give me 17. And then if I added another 6, I would get to 23. So in fact, it does work. All right, let's look at the next one. What do I see here? Well, this one's pretty easy. I know that X's are going to be the same. How many do I have? I have 2X equals 16. That X is multiplying with the 2. What's the inverse operation? What do I need to do? I'm going to divide both sides by 2. And I end up with X equals 8. Okay. The next one, I see 3 X's. So I'm just going to write that down, 3X. And again, if I'm stretching this out to equal this number, then I'm adding everything together. So it's 3X plus 7 equals 16. I'm going to work my way to the X eventually, but I want to get rid of everything else that I can. The further away, the better. Okay, so I've got this 7 here. I'm going to subtract 7 from both sides. These are going to cancel out because positive 7 and negative 7, they're opposites, and that gives me a 0. So now I have 3X equals 16 minus 7 is 9. I'm going to divide both sides by 3 because these two are multiplying. This is going to cancel out, and now I just have X equals 9 divided by 3 is 3. Okay, let's look at another one. This time I only have one X. Poor little X, all by himself. So I'm just going to write down X. And again, if I'm putting these two together to equal this, that means I am adding. So X plus 9 equals 13. We save the easiest for last. Want to get that x by itself because then I'll know I have solved it. Notice in all of these, what did I do? I got the x by itself. Okay, so x plus 9 equals 13. I'm going to subtract 9 from both sides. And I get x equals 4. Okay, great. So that's if they give us a tape diagram and they want us to look through it and kind of come up with an equation or solve an equation. Let's look at something just a little bit different. So here's a word problem, and we're going to look at these two down here, and we're going to see if we can solve them and figure out which one of these two tape diagrams represents this problem. So Jody got t-shirts for her running team. There are 8 people on the team. That's important. 8 people on the team, and I bet each one of them is going to get a shirt, right? The shipping cost was $5, and she spent a total of $93. This is also very important. How much was each shirt? So we got to remember what we're looking for. Now, here's a trick for you. Whatever the question is asking, they're asking us because it's an unknown, right? And variables equal unknowns. So always look back at the question so that you can know what your variable stands for. And in this case, how much was each shirt? That X is going to stand for the cost of each shirt. So I'm going to write that down. X equals cost of each shirt. Okay, that's what X equals. So the cost of each shirt. So what are these other numbers all about? Well, there's 8 people, so I know there's going to be 8 shirts, okay? The shipping cost was 5. I have to ask myself, does that happen over and over again? Or does that just happen one time? That just happens one time. They're going to take a box of 8 shirts and they're going to mail it to me. They're not mailing them separately. So this is a one-time amount, just a one-time amount. But let's talk about that. So the shirts are an 8-time amount, right? The shirts are happening 8 times, and it's a total of 93. So I'm going to say that this is 93 or this is 93. So I want you to stop and think just for a second, what kind of questions could you ask yourself? What kind of things might help you figure out which one of these tape diagrams works? Well, one thing for sure is that we looked at the question, how much was each shirt? This is the unknown. This is what they're looking for. And the unknown and what they're looking for, well, that's why we use variables, right? So X is the cost of a shirt. And how many shirts are there? There's 8. So that means that my equation needs to have 8 x's. Okay? This one puts the 8 in the wrong place. This one has 1, 2, 3, 4, 5, 6, 7, 8 x's plus a 5, and altogether that works to 93. Well, that seems to work for me. So I'm going to eliminate this one and say, no, 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 that's not the one. Well, let's look at this one and see if we can write an equation. How many x's do I see? I see 8 x's. I also see a 5. And again, if I'm putting them all together to equal this, that means I'm adding. And the total is 93. Okay, I want to work my way to this x, but first I got to get rid of the 5. So I'm going to subtract 5. These are going to cancel out. I have 8x equals, well, what's 93 minus 5? 93 minus 5. 88. Since the x is now multiplying by an 8, I want to get the x by itself, so I have to undo the multiplication. I have to do the inverse, which is dividing by 8. And whatever I do to one side, I got to do to the other. So I have x equals 11. Now, what is 11 exactly? 11 what? Well, the question was asking how much was each shirt, and we defined x as the cost of each shirt. So I'm going to down here say each shirt was $11. And there's a nice complete answer. Okay. One more page we're going to look at here. Rashid studies his vocabulary list for the same amount of time, 3 nights each week. He spent a total of 72 minutes on his vocab last week. So how much did he spend each night that he studied? This time we have to make the diagram ourselves. Okay. So we are going to put some things together to be 72. We know that's going to be our total. But what are we putting together? Let's look carefully. Rashid studies his vocab list for the same amount of time, 3 nights each week. So I'm thinking we're going to have 3 of something. And it does say the same amount. So remember, if we have a variable that's represented a couple of 2 or 3, 4, 5 times, it's going to be the same amount. So it looks like maybe we could say, here's Rashid's week, and it says he studies for 3 nights on the vocab. And since it's the unknown, we're going to go ahead and call that our x. Because remember, how much did he spend? That's the unknown. X equals time spent each night. Okay, so we have 3 x's all together. It's 72. So my equation is 1, 2, 3x. Let's write it over here. 3x equals 72. Okay, I'm going to divide both sides by 3 because I notice they're multiplying and I want to do the opposite. Cancel. X equals 24. Now I got to ask myself what? Well, that's the amount of minutes that he studied. So my final answer is he studied 24 minutes each night. Okay, last one. Kevin bought 1 box of candy. That's important. 1. So that's telling us it's only going to happen 1 time. We're probably not going to need to multiply it. Doesn't look like it's going to be a variable because it's Kevin bought 1 box of candy. And 7 long-stemmed roses. I wonder how much those roses cost. Are they going to tell us? He spent a total of $47. How much was each rose? Again, if the question is asking us how much each rose was, they're asking us something they don't know. They're asking us the unknown, and that's what variables are for. So I'm going to take this question and right away I'm going to define my variable. How much was each rose? X equals cost of each rose. Okay, so let's look one more time here. So 1 box of candy for 19. So I can just write 19 into one of my sections of my tape diagram, and 7 long-stemmed roses. Now I don't know how much they cost, that's the unknown, but I do know there's 7 of them. So I'm going to draw a diagram. It's going to be kind of little. X, 2, 3, 4, 5, 6, 7. So I have 7 X's because I have 7 roses and I don't know how much they cost, but I do know that there's $19 there. And I know that all together it's 47. So let's write that equation. 1, 2, 3, 4, 5, 6, 7 X's. 7X plus 19 equals 47. Okay, so let's go ahead and subtract 19 from both sides. Cancel, cancel. Now I have 7x left, and 47 minus 19 is 28. They're multiplying. I'm going to divide both sides by 7, and I get x equals 4. Each rose was $4. Okay. I hope that helps, guys. I really do encourage you to go back. If you didn't do the work from last week, go back and do it. Okay. You want to have a little practice with this on your own, and that way you'll feel a lot more confident going forward this week. Okay. Good luck to you. My office hours are 3 to 4. You can email me. You can communicate with me. I'd be so happy to help you. All right. Have a great week.